Hello everybody. For this next section, 9.3, we're going to be taking a look at how we write the equation of an ellipse in the coordinate plane. And it's very similar to that of we get for the equation of a circle because the pictures look very similar to each other. If you don't know what an ellipse looks like, there are two versions of this picture that we could see graphed. You could have an ellipse that's stretched out longer horizontally than it is vertically, or obviously you could have the opposite effect, an ellipse that is stretched out longer vertically than it is horizontally. Okay. So the equation is very similar to that of a circle because the picture is. We just have to account for the fact that it's no longer a perfect radius. This is longer left to right than it is top to bottom, and in this case, vice versa. So the equation gets a small adjustment from it. We have the x minus h squared, and we still have the y minus k squared. So h and k are still the center of our figure, except now we make the adjustment because we no longer have a radius. We have a squared and b squared. A squared, or the a specifically, is the major axis, while b is the minor. Now this equation matches up to the first picture, and the way to know which picture it is to look at the major axis part. Major is attached to x, so it's longer horizontally in x than it is in vertically for y. If we wanted to write the equation of this picture, it would be the same equation format, x minus h squared and y minus k squared, but we would have to shift where a and b are located. This picture is taller than it is wide, so the a squared would have to be over here with y, and the minor b squared would have to be attached to x, and would still be equal to 1. So we'd still have the same equation format. It's just a matter of if we know it's longer left to right versus top to bottom, where does the major go and where does the minor go as a consequence. But otherwise, it's still this very similar question to the circle problem. The center will be h and k, and though it's not technically a radius, think of it as large radius, the side that's stretched out, minor, smaller radius, the part that's not as stretched out. If a and b were equal to each other, you could multiply out as a common denominator, and that's how you would turn the 1 into an r squared if it was a circle, which makes logical sense. If it was the same left to right as it was top to bottom, that would be your perfect circle at that point. As far as examples go, they run just like the circle questions did. So for the first example here, we're asked to write the equation of an ellipse that's centered at -3, 5, with a horizontal major axis of 2 and a minor axis of 1. So now we start thinking about exactly what's going to happen here. So we know we have a center, we'll call this h and k. Horizontal, which means my a should be tied with my x fraction. And we now know the value of a and the value of b. It's a matter of write out the equation and plug the numbers in the correct spots. So x minus h squared divided by a squared plus y minus k squared divided by b squared will end up equaling 1. We know a should be attached to x because we were told it's a horizontal major axis. Now it's just a matter of fill in the values. So x minus the -3 will become x plus 3. We were told a was 2. Squaring it creates 4. Plus y minus the 5, just literally is minus the 5 squared. And then over, we were told that b was 1. 1 squared stays 1. This fraction we can clean up. You don't really need to write over 1. So you'll see a lot of times it'll just be written as x plus 3 squared over 4 plus the single quantity y minus 5 squared equaling 1 to be the equation of ellipse. And if you double check it here, you're at -3 because of the sign change, and 5 because the minus is supposed to be there. 4 is here, so it must be stretching 2 units left and right, and there is an understood over 1, so it must be stretching 1 unit top to bottom. With that kind of logic, you can now do all of them. It's the idea. So the equation of an ellipse centered at negative 12, 8, this has to be h and k again. Vertical major axis, so my a should be tied to my y fraction, and there's the value of a and the value of b. So we'll start with x minus h squared, but this time it's over b squared because the major is vertical, so it should be a is in the y fraction, plus y minus k squared over a squared equaling 1, and let's go fill in our values again. So x minus the negative 12 will be x plus 12 squared. B, the minor, 3 squared gives me 9. Y minus 8 just stays this expression, y minus 8, nothing special there. And major was 6, squared would be 36, to end up equaling 1. The rest of the questions, we're going to do the same basic idea. We just got to think about exactly how far each thing is. Okay? So, for the next one here, we're already given the equation. You're asked for the center, the major, the minor, based off of this equation. Well, let's start working off the center first. The center has to be h and k. So, if we go up here, we have x minus 5, so we know we've got a 5 for the x-coordinate. Y plus 3 would have been y minus negative 3, so we know we have negative 3 for that coordinate. So we've got our center point. Now major and minor is a matter of knowing which one is tied to which fraction. So we'll use a little bit of common sense. 49 is clearly larger than 4. So the major is horizontal because it is tied to the x fraction, and the square root of 49 gives me 7. The minor is the vertical, and the square root of 4 gives me 2. Now, a good thing to note here is sometimes you get questions that ask you for what is the length of the major axis, for example, or the minor. You can be asked either one of them. Be careful. You found this value of 7, but think about the picture if you actually draw it out. What you've been told is your center is at 5, negative 3, so somewhere about here. I'm not going for perfection here, but you've been told that your major, your A value is 7. Remember that that is 7 units in both directions. So if you get asked for the length of an axis, you need to remember to double them up. The length of the axis is 14. Not specifically asked in the question, but it will come up in some of the practice problems as we go through the section. For example 4 here, the center, the major, and minor of this equation. So we'll work out the center first because it is the easiest part to find. We just have to check the signs and be good to go. H comma k. If we go up here, we have x plus 11, so it must have been x minus a negative 11. So we know the value of h. We also have y plus 19, so it must have been y minus negative 19. So we know our ellipse is centered at negative 11, negative 19. Now for major versus minor, again, we'll exercise the common sense. Which denominator is bigger and which fraction is it tied to? 81 is clearly larger than 36, so the major is vertical because it is tied to the y fraction. So we have a vertical major axis, and square root of 81 provides me that a must be 9, which forces the minor to be horizontal, and the square root of 36 gives me that b must be equal to 6. The only other skill left besides writing an equation or reading an equation and getting the details from it is can you do it with an actual picture. So we'll go ahead and figure out the center here. If we come to 2, negative 1, so we have our center. Our center point sits at 2, negative 1. Now for the values of a and b, you can do this one of two ways. You can actually just start at the center and count your way out to the end, Or if you're told the entire length, like for example, from here to here is 6 units, so then the major for A must be 3. It must be 3 going to the right and 3 going to the left. Similar logic for B. From top to bottom, 1 all the way down to -3 is 4 units, but cut in half would be 2. There's 2 going up and 2 going down. Now that we've got that, it's back to the same first questions that we did on the previous page. We know all we have to do is just write out our equation form and fill it in. And it is clearly horizontal. It is longer from left to right than it is from top to bottom. So x minus h squared over a squared added to y minus k squared over b squared will be equal to 1. And let's go fill in the numbers that we just found. So x minus 2 squared is good to go. A was 3, so it must be over 9. We have y minus k squared, but y minus -1 will get its sign change work, y plus 1 squared. Minor was 2, so squared makes it 4, and equal to 1. Equation is always equal to 1. That's a guarantee. The only other example that you should think about, and it's not specifically listed in the notes here, is very similar to what you saw in the equation of a circle. You may get a problem that's actually not written in perfect standard form like this, and you would have to do completing the square to correct for it. You saw that in the previous section with the equation of a circle. It does come up in a couple of questions here in Ellipse as well. Since the equation forms are so similar, you still do the same completing the square work and figure out the numbers from it. You'll see that when we go through a couple of examples in the practice set. So you'll definitely get your chance to work on it from there. If there's any questions, anything, make sure to ask your teacher, and see everybody in the next video.